Hi everyone, so today I'm going to discuss about indefinite integrals, how we can use the power rule. So last day also we discussed about the power rule as an example. If we need to integrate x to the power n, we learned that it is equal to x to the power n plus 1 divided by n plus 1 plus some constant. But the specialty of the today is we are going to consider about the integral of power of functions. As an example, integral of fx to the power of n or ux to the power of n, how we can do such things. So if we go to today's lesson as an example, this is the basic theory we are going to learn today. So here u is a function of x. As an example, I can write u is equal to f of x. Then if we got such a expression u to the power n times u prime x, so we can write it as in this way by converting un to the power du. So first we need to consider about differentials. So what are differentials? Do you have any idea about it? If I explain like this way, we know dy over dx, but if we consider dy separately, so it becomes a differential. Here's a definition of the differential. If y is equal to f of x is a differentiable function with derivative dy over dx is equal to f prime x, then dy, this is called the differential. So we can write it as f prime x times dx. Let's consider some examples. So first find if y is equal to this given function x to the power 3 minus 4x square plus 5, then you need to find dy. So first we have to use given definition. This is the given definition. Dy is equal to f prime x times dx. So calculate f prime x. We call it as dy over dx. So you need to find the derivative of this given y. It becomes 3 times x square minus 8x. So now you need to substitute for f prime x this value, and you can take dx as same way. So this is your differential. Let's move to our next problem. Here you need to find du. Sometimes dv, du, dx, dy, we call these all things as differentials. So u is given as this function, then du over dx is f prime x. So this is the definition of the differential du. So find f prime x. So it becomes 20 times x to the power 3. Then you need to substitute for this f prime x and times dx. So this is the differential. So these are some basic examples. If we are given some function, how we can calculate the corresponding differential of it. Then let's move to the power rule very deeply. Let's see how we can solve such problems. So this is the basic theory as example explained before. Here u is a function of x, and if we are given such a kind of integral u to the power of n times u prime x, this is the integral. So here you need to memorize this crucial point. So when you are given some problem, especially they are given in this type, so you no need to worry about it, but you must be able to understand that this problem is in this type, I mean this power rule integration type. Then you can do it very easily. After doing some examples, you can understand it. And also if u is a function of x, you can do it, I mean this may be a linear function in here. U is linear. You can use this formula directly. but here the specialty is u must be linear. It means x plus 1 or 2x plus 3, like this way. It can't be quadratic or cubic or any other higher order polynomial. Definitely it must be a linear, then you can use this given formula. So this is your first problem, so you need to evaluate this one. So first you need to think what is your u. So first thing, like this is u. If this is u, what is the derivative of u? So u prime is this one. So now you can have some idea that if we consider this type, it is in u to the power n times u prime dx. Then you can write it in this way. Or in other words, this one I convert to this here, so you can understand this is your u x to the power n, then this is your u prime x, then directly you can write this formula. So u to the power 6, because here our n is equal to 5, then 5 plus 1 is 6, divided by 5 plus 1 is 6 in here, plus constant. So now replace with the original function, so it is 3x squared plus 4. So this is the answer for the integral of this one. Then let's move to our next problem. This is the problem 2x squared minus 4x to the power 2 times x minus 1 dx. So here also first substitute, this is u, then u prime is this one, but here the crucial point is you can factorize this as 4 x minus 1. So now you can create x minus 1 in here, so you can write like this way. This one you can convert like this way, then you know this is the derivative of 1, I mean x minus 1 is the derivative of this 2x squared minus 4x, this one. Then you can make this setup. So here you need to understand your n is equal to 2. Then use the usual formula, so it becomes u to the power 2 plus 1 u to the power 3 divided by 3 plus c. This 1 over 4 comes because of this 1 over 4. So this is your final answer in here. So this is some different kind of problem. I mean this has a numerator and denominator. First take this into your numerator, so it becomes x to the power 3 minus 3x to the power negative 3 times x squared plus minus 1. So think now this is your u, then derivative is this one. So here also you can factorize it as, if you take 3 out of the bracket, it becomes x squared minus 1. So you already have it. Now you can write your setup. So this is your u to the power n times this is your u prime. This is u prime and this is u to the power n. So here specialty is n is equal to negative 3. You need to understand these things to solve this problem. Then use that formula. So negative 3 plus 1 means negative 2 here, and negative 3 plus 1 is negative 2 plus c. So this is the final answer. So now we are going to solve some application problem here. Suppose that the marginal revenue for product is given by this formula. So we know if we differentiate the revenue function, we can obtain marginal revenue. So consider the vice versa. I mean, if we integrate the marginal revenue, then we can obtain the revenue function. This is equal to revenue function. So to obtain this revenue function, I integrate this marginal revenue. So you can obtain this expression. Here you can see that this is one function and this is one function. So separate it into two pieces, this one and this one. Then you can obtain the second part very easily, this type. So it becomes 2 times x plus some constant. You already have done such things. To find the integral of this one, you have to use this formula. So here also you need to understand what is your u first. So your u is 3 times x plus 1. So as I told you before, If u is a linear function, you can use this formula directly. So here 3 times x is a linear function because the reason is it doesn't contain any quadratic or cubic or any other higher order polynomial which is greater than 1. It doesn't contain. Then directly you can use this formula. So first understand this is your u and n is half. So now it becomes sorry, n is negative half, so it becomes negative half plus 1 means positive half, and also for the denominator also negative half plus 1 is positive half. So this is the final answer for here. Now you can write like this way. So if we need to find the value of the constant, we know when x is equal to 0, revenue is also equal to 0, then we can obtain by substituting k is equal to negative 400. So this is your final revenue function. So in here also this slide contains some formulas. I think these are helpful to solve some problems, especially when you are doing some homework. I suggest that write these things in some separate paper, then do your homeworks by yourself, because this section is very important. Although you are management or accounting or engineering, for any side you need to learn integrals. So especially this is a very important section. Thank you everyone, and let's meet on next class.